All right, so this question is asking us to determine the type of growth that is shown by the pattern. It's also asking us to write an expression that represents that type of growth and determine the number of squares in this fifth step. So I like to start by just recognizing the total number of squares in each step. So step 1, we notice we see 5 squares. Step 2 has 9 in the middle and 2 on the end. That is 11 squares. Step 3 has 15 in the middle. That's 5 times 3. And that's 2. That's 17. So how is this changing? We're looking at the change from 5 to 11. That is a plus 6. From 11 to 17, that's also a plus 6. So one of the things that I can recognize initially is because there is a constant rate of plus 6, I can tell that this is representative of linear growth. And the equation that is used to represent linear growth is y is equal to mx plus b. I am gonna just do an additional step, which is let's look at step 4, just to make sure the pattern is continuing. So what do I notice about step 4? Each step, I notice that there is an extra 2 on the ends in the middle row of each pattern, but also there are 2 additional columns that are added each time. So if I wanted to represent step 4, then for me this is what my step 4 would look like. It's 1, 2, so that was 5, so I need to have 7 here. 3, 4, 5, 6, and then that should be broken up into 3 rows. So I have 1 here, 2 here, and then my extra coming from the middle, extra coming from the middle. So this is what my step 4 looks like, and there's my additional 2 pieces. And so this would be 7 times 3, 21, plus 2, 23. And we're noticing that that pattern continues because from 17 to 23, that's a plus 6. So we know our constant rate of change is plus 6, and we can show the same thing on our table. You can use either of the strategies that best suit you. So from 5 to 11, that's a plus 6. From 11 to 17, that's a plus 6. And we just discovered because it's plus 6, we can add 6 this way, which is going to give us 6 plus 17, that's 23. But we also saw the pattern up there. Now we need to find the b term in the expression, which is step 0. So b is equal to step 0. And to get to step 0, I can do the reverse of what I was doing initially. So if I go from step 1, I'm going back. Instead of adding 6, I would subtract 6. If I take 5 minus 6, that's going to give me a negative 1. So I know that this is negative 1. That was not something I knew initially. So in this case, since I know that b is equal to negative 1, my b is the same as my y-intercept. For this equation, the expression is going to be y is equal to my constant rate, 6m plus 6x, plus my b, which is negative 1. I can also write that as y is equal to negative 6. Y is equal to 6x minus 1.